Hello, my name is Shamadrin. Today, we're going to be controlling a servo motor using a potentiometer. Servo motors are used where precise movement is required. Early RC airplanes and cars used servo motors for steering precisely. Parts needed. One servo motor. When a servo motor has passed a PWM signal, it can turn to a specific angle and stay in that angle. So servo motors can turn between 0 through 180 degrees. And it has three wires. One is a power wire, the other is a ground wire, and the final wire is a signal wire. So here is a picture of our servo motor. It cannot be directly connected to our breadboard, so we attach wires to it. So this one is the 5 volts, the red one. Our white one is the control, and our black wire is the ground. And we also have a picture of some servo mounts, which we connect to our servo shaft. So what these basically do is that to make it more visible of showing that our servo is turning, we use servo mounts. And then we use one potentiometer. So in order to control our servo's position, we use a potentiometer. As we adjust our potentiometer, our servo will turn accordingly. And finally, we need 8 jumper wires, which are used to connect our circuit together. So here is our potentiometer with its knob and 3 pins. Here's what our servo would look like. Duty cycles. In order to generate servo control signals, we use pulse width modulation. Pulse width modulation can also be abbreviated as PWM. The length of time in which a PWM signal is on is called a duty cycle. Duty cycles are measured in percentage. For instance, in a 100% duty cycle, the signal is on 100% of the time and it never lowers. In a 50% duty cycle, the signal is on 50% of the time and is off 50% of the time, so the bars equally match. And in a 25% duty cycle, the signal is on 25% of the time and is off 75% of the time. And based on these variations in the duty cycle, our servo motor can be told where to go and where to be positioned. To position our servo motor, we send it PWM signals. Writing the code for these PWM signals can be really tiring, so our Arduino IDE has libraries which you can use for these projects. One of these libraries is the Servo library, which has codes that are specific to our servo motor, and we can use in projects which involve a servo motor. In order to import a library, the first thing we do is that we say #include, which is like a link to the library's header file. And then what we do is that we say servo.h, and in this case, we are importing the servo library's header file. So what a header file is that it's just basically a small file that stores the definitions for the functions in our library. Methods and objects. So that now that we've imported the servo library, the first thing that we can do is that we can probably create an object with it. The first thing that we do for that is that we first say the name of our library, which in this case servo, and then we tell the object name. So this can be anything, but in my case, I'm just saying my servo. And my servo is an object. So objects can be used to store values, and they can have their own functions, which are called methods. So an example of a method could be in our servo library. A really common one is .write. So that is one of the methods for our servo library. And this can basically tell our servo to move to a specific position. For instance, my servo.write 90 is like this, basically telling that this is the object, my servo, and we're telling its function that it should move about 90 degrees. Safety. When working on a circuit, make sure the board is not connected to a power source, such as a USB power source or battery power source. Now let's see the circuit diagram for our project. This one is Sparks from the VentureScape website. So today we're actually dealing with a really simple circuit. So now let's begin. volts from our breadboard is connected to the common power. The common ground is connected to the ground on our breadboard. Our potentiometer is attached from pins B1 through B3. The power pin of our potentiometer is attached to the common power. The ground pin of our potentiometer is attached to the common ground, and the output pin of our potentiometer is attached to the A0 analog input pin on our breadboard. Our servo motor has 3 pins, but they cannot be directly connected to our breadboard or our breadboards. So what we do is that we attach jumper wires to those pins. So the red jumper wire is meant to be the common power, and that is attached to, the power of our servo motor, and that is attached to the common power. The black wire is the ground of our servo motor, and is attached to the common ground. And the white jumper wire is supposed to be our signal, and that is attached to digital pin number 9 on our breadboard. So this concludes the circuit diagram. This is the Arduino IDE. The sample code is from the Sparksman Inventors Kit website. To go to our code, let's go to Files, Examples, SIKGit Codemaster, and let's go to 3A Servo. So now let's begin. The first thing we're doing is that we're saying hashtag include servo.h. So what we're doing here is that we're basically importing the servo library. And now what we're doing is that we're saying in pot position and in servo position. So we're creating 2 variables, which are called pot position and servo position. And the next thing that we're doing is that we're saying servo my servo. So what we're doing here is that we are creating an object, and in this case we're calling it my servo. And servo basically just tells it's in the servo class inside of the servo library. Now in void setup, which only happens once, we say my servo.attach 9. So what this does is that it basically just says, again, my servo is the object and .attach is the method. And what this .attach basically tells our code that the 9th digital pin on our breadboard is connected to our servo motor. Now in void loop, which happens forever, we say pot position is equal to the analog read of A0. So what this does is that we're basically saying that our pot position variable, we say that is equal to the analog read of A0, which will output a value between 0 through 1023. And then in my servo position, I say that it is equal to the map of pot position, 0, 1023, 20, 160. So what this basically does is that the map position, we take the map position and we say that it's currently telling the value of our potentiometer, and we say it's in a value between 0 through 1023. So our pot position value could be anywhere between 0 to 1023. And we want to convert it into a value of between 20 through 160, where 0 is the least value of our potentiometer and 1023 is the highest value of our potentiometer, and where 20 is the lowest value of that our servo motor can spin in so it doesn't break or anything, and that 160 is the highest value which we can do so it does not break or anything. So again, like what this map function does is that it's all stored in the value called servo position. And the reason why we're not going to any of the extremes of our servo motor, like 0 or 180, is because like that could cause our servo motor to jitter or to break. So we don't want it happening. So we take it to a limit of between 20 through 160. And then we do my servo.write servo position. So what this is that, again, .write is a method and the servo is the object. And we're basically telling our servo that we want to spin we want it to turn this many degrees based on our map function's return value. So like it can be anywhere between 20 through 160. So that value. And this ends the code section. Now let's start the assembly of our projects. Here is our base plate with our breadboard and breadboard on it. Here is our servo motor with its connector. And this is the place in which we can attach those jumper wires so we can connect it to our breadboard and breadboard. And this top white part right here is where we can connect our shafts. Like here's just some of the shafts that we can use. Like this one. Like, and these shafts are used to see our servo motor spin. And today I'm just going to be using this shaft. You can use any one, but I just prefer this one. Here is our potentiometer with its knob and 3 pins. And here are our sets of jumper wires. So let's begin. So I'm first going to take this servo motor, and our servo motor is polarized, so we've got to make sure that our pins are connected to the right slots. But thankfully, they are color-coded so we can see them easily. There's this red, and in the middle there's black, and the red represents the they represent the power, the black represents the ground, and this white represents the signal. So now I'm going to just keep it, and I'm going to attach this red jumper wire to one of the places, and I'm going to attach it to the middle slot of the place in which we can connect it on our servo motor, and I'm going to attach that place to the common power. I'm going to do this here for now. I'm going to take this black jumper wire, and I'm going to attach it from one of the ending slots, and I'm going to take its other side, and I'm going to attach it to the common ground. And now I'm going to take this white jumper wire, and I'm going to attach it to digital pin number 9 on our breadboard. And now I'm going to take this potentiometer, and I'm going to attach it from pins B1 through B3. And now what I'm going to do is that I'm going to attach this red jumper wire, and I'm going to attach it from the positive terminal of our potentiometer to the common power. And I'm going to take this black jumper wire, and I'm going to attach it from the negative terminal to the common ground. And finally, I'm going to take this blue jumper wire, and I'm going to attach it from the output, which is the middle pin, to analog input A0. And now I'm going to take this red jumper wire, and I'm going to attach it from the 5 volts on our breadboard to the common power. And I'm going to take this black jumper wire, and I'm going to attach it from the common ground to the ground on our breadboard. So now what I'm going to do is that I'm just going to take this shaft, and I'm going to attach it onto our servo motor. So this concludes the assembly of our project. We finished building our circuit, and now it's time to upload code to it. I'm first going to take this USB, and I'm going to attach one end to my breadboard, and I'm going to attach the other end to my computer. So now I'm going to share my screen and I'm going to show you the Arduino IDE. And here is our Arduino IDE. So I feel like I kind of want to add, I kind of want to show the value of our potentiometer and the servo's angle. So I'm going to add a few lines of code, and I'm going to show those values in our serial monitor. So the first thing I'm going to write is that serial.begin 9600. So what this means is that it's basically just starts the connection between my circuit and my computer. So, and 9600 is basically the baud rate, and that is basically 9600 BPS or bits per second data transfer. And now I'm going to write in void loop a few print statements. The first thing I'm going to do is that I'm going to say serial.print. Then I'm just going to put in double quotes, just like nothing, because somebody is going to put that. And then what I'm going to do is I'm going to say, serial.println. And then I'm going to do serial.print. And in double quotes, I'm going to say potentiometer. And then I'm going to put a colon. And then I'm going to say and this basically does that. It simply puts the string in our serial monitor of potentiometer colon. Somebody's going to print that. And I'm going to say serial.print. Okay, the variable is position, so position. And what this does is basically in the same line as our potentiometer, we basically just write like the value of our potentiometer. And now I'm doing serial.print, and now I'm going to create another string, and this time I'm just going to put a space first separation between my servo and my servo value and like the servo string and my potentiometer value. I'm going to put a space, and then I'm going to say servo, and I'm going to put a colon, and I'm going to end the string. And then I'm going to say serial.print, and then the variable is servo position, so I'm going to write servo position. So this basically shows us the value and the angle in degrees of our servo. So now there's this upload button, which I'm going to click on in order to upload our code. So I'm going to click on it. It's compiling a sketch, and it's uploading. And it's done uploading. So now I'm going to share screen, and I'm going to show you my serial monitor. So the value of my potentiometer is currently at 0. So the value of my servo is currently 20 degrees. But if I turn my potentiometer all the way to the other side, we get a value of 1023, and my servo is showing a value of 160. And if I put it somewhere in the middle, like for instance, our potentiometer is giving us a value of 688, so then my servo is going to give me a value of 114. So now see it based on my potentiometer, value, My servo also spins in that same way. It can spin anywhere between 20 through 160 as per our code. So whenever I spin it clockwise, you can see that our servo is also turning clockwise. And whenever I turn it anti-clockwise, you can see that our servo is turning anti-clockwise. So now I'm just turning it around a bit.